A nice thing about differential equations is that you can always check if a solution is actually a solution to a differential equation by just plugging it in, right? And you're familiar with this idea from algebra. So for an algebraic equation, we could ask, is x plus 2 a solution to 5x minus 3 equals 7? And the way you would check is you would take that proposed solution, plug it into the left-hand side, and plug it into the right-hand side. So if you plug into the left-hand side, right, you have to evaluate 5x minus 3. You plug in 2, it's 5 times 2 minus 3, that's equal to 7. Okay, then you have to plug into the right-hand side. Here, it so happens that there's nothing to plug in. The right-hand side is already just equal to 7 up here, right? So then you have to check, is the left-hand side 7 equal to the right-hand side 7? It is, and so x equals 2 is indeed a solution. The idea is very much the same with differential equations, right? So let's take a candidate solution, y equals e to the minus x squared over 2, and ask if it's a solution to y prime equals minus xy. We're going to plug that solution into the left-hand side, and what plugging it in means is differentiating it, since the left-hand side here is just y prime. So I evaluate y prime for my candidate solution. It's minus x e to the minus x squared over 2. Then I look at the right-hand side of the equation. That's minus xy. So I have to do minus x times my proposed y. So that's minus x times e to the minus x squared over 2. Then I check. Does the left-hand side equal the right-hand side? It sure does, so indeed, this is a solution. One last example. All right, so we can ask, is y equals minus natural log of x a solution to y double prime equals y prime squared? And we're just going to pre-compute some derivatives for convenience. I'm going to calculate that y prime is minus 1 over x, and I'm going to calculate y double prime is 1 over x squared. So I plug into the left-hand side, meaning I evaluate y double prime for the candidate solution, and we did that already. It is 1 over x squared. Then I evaluate the right-hand side. Right-hand side is y prime squared. That's negative 1 over x quantity squared, which is 1 over x squared. Left-hand side equals the right-hand side, so we're good to go. This is indeed a solution to the differential equation.